All right, this is the Algebra 2 Week 2 video. We're getting ready for equations in Algebra 2. All right, I'm just realizing, we should have come from geometry. So, might have not seen some of the stuff since Algebra 1, but hopefully this you definitely saw. Okay, and I'm going to show you the way that I like to solve equations, which is a little different than the way some teachers do, but I think it's efficient. At this point in your math career, you should understand how equations work, the balancing, and that we're taking away things and adding things. All right, and keeping the balance, the equals. So now with these multi-step, let's just put our variables on the left, numbers on the right, and then we'll just be able to combine like terms, because essentially it's all about combining those like terms. So here's our original equation. Drop a line under the equal sign, and let's put the variables over here and the constants over there. And if it goes over the line, changes its sign. So 4d minus 5d. Put that over, change the sign, and then the -8. Bring that down. So this guy, -4, that's going to go over. That's going to change the sign to be +4. Follow that. Now we're going to combine the like terms. So this is going to be -1d. This is going to be -4. Then we just solve our one-step equation. D equals +4. Of course, you can check your work by substituting it back in. And then when you press the check button, you'll be right. Answer 2 questions about equation A and B. How can we get from equation B? How can we get equation B from equation A? So if I'm looking at equation A, I notice I'm looking for the difference. So 5x minus 2 plus x equals x minus 4. 5x plus x equals x minus 4. So the only difference that I see is the -2. So I don't really think that you can. Oh, I see. Add or subtract a quantity to one side, but that doesn't make, they're not equal. That's how you do it. So are they equivalent? No, because only one thing changed. Okay, so solving this one is the same as the other one, but this time we have the distributive property. And when you use the distributive property, make sure you don't forget to distribute the negative. Then it's going to be 3 minus 18, and then -2 times 2 is 4, is -4. All right. Now we are going to combine our like terms. So that's going to be 3 minus 18 is -15 minus 4m. Now we're going to put our variables on the first one. I put the variables on the left. This time I'm going to put them on the right. The whole point is to put them on the same side, not have to do it one way. So now they're on the right side, and I can combine them. That makes 5, and now I can divide. And what is the equal? It equals -3. Of course, I could check my work. All right, so that should get you started with the equations now. And you should already be started. That was like 8th grade math right there. But it's all right. I'm just saying that's what it was. Now with this one, which of these strategies would eliminate a variable in the system of equations? So when you're looking at the system of equations, first I notice they're both in standard form. Second, when I look at the y's are opposites. So you could add the equations and it would eliminate the y's. If you subtracted the equations, then if you subtract the x's would cancel because right now they're the same. But if I subtract one, then they would become opposites. So there you go. How can we get system B from system A? So let's look at system B and system A. The bottom are the same in both. But the top, it looks like 6 went down by 2. So, maybe we added. And then the 5 went down by 2. And so we up by 2. So it looks like, and then even the 1, we add it becomes 0. So looks like we take the second equation and add it to the first. Where's that? Where is that? Replace one equation with a multiple of itself. Replace one equation with the sum and difference of both equations. Okay, that's that one. And that is the top was replaced by the sum of both of them. And are they equivalent? Yes, they are, because that is a valid strategy in system of equations. It's actually a very sophisticated strategy. And we can talk more about that later. But we're going to solve this traditional way. You should know there is substitution, elimination, and graphing. Those are the 3 ways you solve a system. Because these are both in, there's also 3 forms of linear equation. There is slope-intercept, standard, and point-slope form. All right, so please write down slope-intercept. You should know that. Slope-intercept, standard, and then point-slope. All right, and y minus y1 equals m, x minus x1. You can ask me about those, but because both of these are in standard, we're going to use elimination. We are going to, and look, we even have opposites in the x's. So we can just add these together. And that would make 7y. The x's would cancel, and this would become negative 21. And if we divide both sides by 7, we get negative 3. Right? So that's easy. Then how do we get the x? We just substitute it back. So now I'm going to take this top equation, and I'm going to substitute negative 3 in for y, and I'm going to solve for x. Negative 6 minus 3x equals negative 27. Now, put that negative 6 over to the other side. It becomes negative 21. And adding 6. And then x equals 7 as well. Oh, y was not 7. X equals 7. Not as well. Just 7. 7 and negative 3. All right, I'm on a roll. Okay. Now this one, they're in slope-intercept form. But also it's asking if that point is the solution. So we don't want to solve it. We want to just substitute in and see if that is the solution. So I'm going to go ahead and put 2 in for y, 4 in for x. And it works out. So it works in the first one. Do that again. I have a bad feeling about this. 16 and 2 are not equal. So I believe the answer is no. Sorry. Result of adding these equations, so you can do that. All right, graphing. Graphing. When you graph the system of equations, you also want to look and see, are they in slope-intercept or standard form? And these are in standard form. What I'm going to do is I'm going to find the intercept. Of course, you could put the equation in slope-intercept form and graph it that way. But I over the years have enjoyed finding the intercepts instead. So I take the term. Oh, and the reason is why? Because I can do it in my head. I'm writing it out for you, but actually I can do this in my head. So I take the x term and set it equal to the number, and that would be 2. Take the y term and set it equal to the number, and that would be -2. So now I can graph one of the lines by putting a point at 2 on the x and a point at -2 on the y. Then the other line, same thing, so 3x equals -18 and 3y equals -18. Divide by 3 and x equals -6 and also y equals -6. They both equal -6. So let's put the points at -6. But of course, this is not just any graph. This is the graph of 2 lines in a system. So we want to know where they cross. That's the solution. And so the solution is -2, -4. That is the point of intersection. Ta-da! All right. So, okay. Now we also have to do this. This is solving by substitution. And take that. How do I know that? Because that second equation is in, it's not in slope-intercept form, but one of the variables is solvable. So we take the expression on the other side, we substitute it in for the x. So it becomes 3y plus 1 plus 4y equals -23. And then you would solve it, and then you would substitute it back in to find 1. Why don't you try that? Okay. All right. Now this is the solution steps for solving this equation. This equation is not the same as the other one because of the exponent of 2 here. This is a quadratic equation. The first step would still be to add 1 to both sides. But after you do that, oh, and then divide both sides by 1/4 or multiply both sides by 4. That gets rid of the 1/4. And then when everything is by itself, then you can square root both sides, not square both sides. And after you do that, then you can, well, then you have x plus 5, so you're going to subtract 5 from both sides. And that's basically, so we can talk more about that. All right, Mitchell solved the quadratic equation. His work is shown below. In which step did Mitchell make an error? All right, so let's look. So the 6 is gone. That was good. And then the 5 is gone. That's good. It was step 3. When you do that, you can't do that because x minus 2 squared would be x minus 2 times x minus 2, which is not equal to x squared minus 2 squared, because we get a middle term, x minus 2, x minus 2. We got to add these 2 terms together. It actually becomes x squared minus 4x plus 4. All right, so step 3. That is a mistake. All right. So now this one here, I'll do this one now. I know I just wrote down the steps for the first one. That may have been confusing. This one is all the way. And what I like about this one is this part is in vertex form. So we're just gonna, we know that we're gonna solve it by taking the square root. Okay, so I'm gonna put that number over on the other side. And then we're gonna take the square root of both sides. And whenever we take the square root of both sides, we have to put a plus or minus in front of it. And then there are two equations we have to write. X plus 7 equals the square root of 11, or x plus 7 equals negative 11. Okay? And then we can actually find the square root of 11, which is 3.32 approximately. So I'm going to just write that. Ooh, right. Okay, and then subtract 7 from both sides, and you get your two answers. Minus 7, negative 3.68. And then this would be negative 10.232. All right, so let's try that. So our lesser is negative 10.32, and our greater is negative 3.68. Look at that. Okay. So that's that one. And now let's look at the last one. Okay. Quiz 4. Now, if you need to take a break, I would totally understand. And I would take a break as well. But I'm not going to. I'm going to persevere through this last quiz. Okay. And also, you know, it's the summer. So if you're like, let me just come back to it. You know, come back to it. It will pay off. It'll be good. So if the quadratic equation is not in vertex form, then it's either in standard form or factored form. So we wrote down the 3 linear forms. Let's write down the 3 quadratic forms. So vertex form is a x minus h squared plus k. It's called vertex form. And then factored is x minus m, a, x minus m, x minus n, and then standard is ax squared plus bx plus c. And there are methods to go from one to the other. Also notice the a is in all of them. Whenever the a is not equal to 1, then things get more tricky. But you also want to look for the GCF every time. So I see this in the standard form, and I also see there's a GCF of 5. So I'm going to divide everything by 5. And I end up with, oh, and guess what? When it's an equation, you can even divide both sides by 5, and the GCF goes away when we're solving. So I don't even need the parentheses. So x squared plus 9x plus, what would that be, 18? And now I'm noticing, you know, I could use the quadratic formula, but I noticed this factors really nicely. How does it factor? Well, we put the x squared in the first box, 18 in the last box. X times x is x squared. And the 2 boxes here have to add up to 9x. So I thought it factored really well. But now I'm getting over. Wait, yep, 6 and 3. 6 and 3. Back. So 6 plus 3 is 9, and 6 times 3 is 18. So this thing factors into x plus 6, x plus 3 equals 0. And that means the solutions are negative 6 and negative 3. So the lesser would be negative 6, and the greater for being negative 3. Which equation is equivalent to 2x plus 3 squared minus 14x minus 21 equals negative 6 in terms of f? Ah, this is a good one. All right, this one troubled my Algebra 1 students too. So this is in Algebra 2 and up, we use substitution sometimes to make things look simpler. So if m is 2x plus 3, then that would make this m squared, wouldn't it? And then let's look for that GCF again, because I'm seeing right here, I can divide them both by -7, and that would make this 2x plus 3. You see that? Pretty cool. So then we would have m squared minus 7m equals -6, or m squared minus 7m plus 6 minus 7. So that's A. That one wasn't too bad, just different. All right. This one, as you can see, the plus minus the square root. They use the quadratic formula. We better use the quadratic formula. All right, so what is the quadratic formula? It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And what is ABC? A is -10, B is -7, and C is 1. They tried to trick us, but I know it's supposed to be ax squared plus bx plus c. Okay, so now we just substitute in, so we're going to get 7 plus or minus the square root of -7 squared minus 4ac all over 2 times a is -10. Then we're going to take and do all that. I usually do a calculator. Alg2. I'm going to do right now. -7 squared minus 4. Only problem is I actually can do it faster. Not easy. All right, don't be like me. Okay, so do I see that? I see that. A. Sometimes the radical is not simplified and we can take out a common factor. Not in this case. The discriminant. Okay, so don't worry. Just a little part of the quadratic formula. It's the b squared minus 4ac. And if it's positive, there are 2 solutions to the equation. If it's 0, there is 1 solution. And sometimes it's negative. There's 0 solution. What does that look like on a graph? 0 solutions means 0 x-intercept. 1 solution means, whoop, that ain't right. 1 x-intercept, and 2 solutions means 2 x-intercepts. So here I see 2 x-intercepts. This has a positive discriminant. All right. And find one value of x that is the solution to the equation. Okay. So now guess what? I'm looking at this one and I see that this one reminds me of that one where I had to let m be 3x plus 2, because I see a squared inside of a square. And then on the other side, I'm seeing a GCF. Both of those things have a GCF of 4. Did you see that? So then now we make that side 4x squared plus 3. And that's what it says on this side. So I have x squared plus 3. So then I'm just going to write x squared plus 3 squared equals, okay. So now I'm going to say let j, my first name starts with j. So I'm going to say j equal x squared plus 3. So then this would just be j squared equals 4j. And then I can put those on the same side, make that negative 4j. I can take out a GCF, j minus 4. And then I can solve that. That means j equals 0 and j equals 4. And so those are the solutions for the j. But we know that actually j was x squared plus 3. And that means 0 equals x squared plus 3. And 4 equals x squared plus 3. Because those are the values of j. Now I can solve that. So this would be negative 3 equals x squared. Oh, that's not going to work. Take the square root. We get the square root of the negative. So we'll have to wait till complex numbers for that. But this one here, we're going to get 1 equals x squared. And when we square root that, we just get plus minus 1. So I'm going to say 1. Amazing. It would just be 1. All right, guys. So, hey, I powered through it. I hope you do the same and have fun and, be happy with yourself for all your hard work. And then post in the organizer.